they confiscated my iPhone so it wouldn't interfere with the sound here, so I don't have a prop. I guess I can use the clicker as a prop. I say pizza. Well, what's really happening there? It's searching for pizza in the speech recognition database in the cloud. It's not doing the speech recognition on the phone. The really important insight came to me when I was having a conversation with Nuance, which is the leader in speech recognition. And they said, the reason why Google is good at this is not just because they're really good at speech recognition, but they know what people are likely to say. Google Suggest, effectively, is another database that they put together with that speech recognition database to get better results. And then, of course, they filter it with the location, which is also reported by the phone. And so, for example, if you did that search right now, you would get those 3 pizza places: Pizza Nostra, Sibel's Pizza, Extreme Pizza, all of which are right here near this location. Okay, this is the Internet operating system of the future, cooperating data systems. But it's also on devices. So we see here an example of a really interesting future. It's an application running on a mobile device. The user interface is driven by sensors. It's not people typing on a keyboard anymore. I mean, there's a touch screen that certainly does a lot of it, but there's also motion and proximity sensors. Literally, you put the phone to your ear and it goes into speech recognition mode. It's got a microphone. These are ears for a cloud application. And then, of course, it knows where it is through either GPS or cell tower triangulation. But this key point, though, also is this cooperating cloud data services, speech recognition, search, and location. And these cloud services are combined to do a job that none of them could do alone. So think about how in your applications you're actually building on, effectively, operating system components that are databases in the cloud. So in terms of just understanding Google's strategy, it's worth thinking about, because we really are entering an era that's a little bit like the old days with Microsoft. You may remember there was a period where VCs would go and meet with Microsoft to understand what areas they should not invest in. We're kind of starting to hit a little bit of that place with Google. They want to understand where Google is going because they have so many assets. We see this with speech. When Google first started offering 411 service, it was free, phone number lookup. I did a blog post on the Radar blog in which I said, oh, they want to get into the speech recognition business. Yeah, maybe they also wanted to get into the phone business in one way or another, but it was clear that they wanted to gather speech data. And sure enough, they later admitted that, and they've now made speech recognition a major part of a lot of their long-term product planning. You look at another one. Google is clearly working on automated translation. Again, another data-rich kind of application that gets better the more data you have. It's showing up through a bunch of their products. In Wave, they have a translation module. I think they really are long-term looking at the Star Trek communicator. They want to be able to translate anything in any language. That's a hugely ambitious vision of where they can go in the future. But I think it's important for you to frame your activities in the context of that future. There's so much power when you can amass huge databases in the cloud and put that to work in an application that perhaps is delivered down to a local device. So you're not just competing and building local software apps. You're not just building web apps. You're building apps that consume and produce data for cloud services. So what I'm trying to get across here is that it's not a PC era operating system that we're talking about. Next story. A little bit more about sensors. A couple of years ago, there was this very cool project still out there called the Quake Capture Network. A bunch of scientists realized that every Mac and a whole lot of PCs have a motion sensor in them. And they built an application a little bit like SETI at home. You run a screensaver or whatever, and it uses the sensors in your laptop to detect earthquakes. It reports in, hey, I just felt a great perturbation in the force. And so we started looking at that, that was one of the things that got us to start paying attention to sensors. And then, of course, we started seeing sensors everywhere. Here's a very cool project that Flickr did. They studied 80 million geotagged photos, and what they discovered was that they can actually reproduce maps using the geotagging of photos. You look at the pink outlines there. That on the top, I guess from your point of view, would be it's top left. Is what photos tell us the shape of the United States is, the shape of Vietnam, the shape of Texas, the shape of, I think it's Akron, Ohio. Cell information is going to make this way more accurate. We're eventually going to have every photo accurately geotagged, and there's enormous amounts of data just being thrown off as a kind of data exhaust by our devices. So some startups are starting to use this. In this very room was demoed a month or two ago at TC50, a company called Affective Interfaces. It's a camera-based app. They have a couple of possible applications, but what it does is it detects your mood when you're looking at, say, an ad. And it says, oh yeah, they laughed at this point in the ad. They lost interest at this point in the ad. The camera is being used as eyes for a machine learning app. It also has applications that they're investigating with automobiles. The car will notice if you're getting drowsy by certain aspects of how you look while you're driving. So this is a future, again, that's the other end of the cloud. The devices we use are starting to produce enormous amounts of data that is useful in applications. There's another one. This is a company that my venture fund funded in the UK called Path Intelligence. These are some guys from the GNU Radio project who recognize that every cell phone is always checking in with the tower. And there's an application in in-person marketing which is counting people in a space. So they could realize that rather than having every year you'll do a survey of foot traffic in shopping malls or you put in surveillance cameras, they can just count the cell phones. Everybody has one now. And they can say, well, all the people walk down this hall, not many people go down there. We used it at our Web 2 Summit last month to say how many people were in the hall at any one time. It's amazing how much data is being thrown off by our devices to be used. So think about what kind of devices your applications are going to be living on, what data those applications, those devices are producing, and how you can use it. Another one, obviously, it's not just from devices. There's hidden data in many of the tools we use. Google, for example, FluTrend, just another application of looking at what they could mine out of their search data. There's an amazing one, again, another O'Reilly Alpha Tech Ventures portfolio company in the UK, Amy. It's a back end for carbon trading and web services involved in the clean tech space. They have smart meter data from a couple of million homes in the UK. And one of the things that they found out is that simply by looking at the power spikes when an appliance turns on and off, you can identify the make and model of every appliance in someone's house. Right? So the information that's hidden in our devices and the new streams that are coming to us are a resource that I think is really worth exploring as you think about this data future. There's also other software applications. There was a project at MIT called Project Gaydar, where some researchers demonstrated by various things that people did online, you could predict with fairly high accuracy whether people were gay. They were trying to, show the implications from a privacy point of view, that it's not just personally, it's not just the explicit personal information, but simply by analyzing social network, certain other kinds of behavior patterns. So privacy is going to be a huge issue. You have to think about it in your applications. You have to think about also, so I guess I'm really offering you both a positive, there's data to be mined and used, and there's also privacy risks and obviously blowback, but also just how do you take care of your users in this world that we're coming at. A wonderful way that I've used to frame this, I actually got from, sorry, I'm forgetting, I have a brain fart. It's somebody else's wonderful name. I'll have to look up where it came from, but this idea that the world casts information shadows. Everything that happens in cyberspace, in some sense, is an information shadow of something in the real world. And a lot of what we're learning to do is to see in those shadows, to read from them what they mean. So, really important lesson for me, and kind of a wake-up call